just going to record it, okay? So in the past, to produce, when we first started grade 9, I think all the way back, we were like produced lines using tables of values. Does that sound familiar? And I took a value of x and I substituted in for x, and then I got out y's. Does that sound familiar? That's all this really is. We call this like on the left here, you can see this is XY notation. That's typically, that's what you've seen, okay? And what we were able to do, if you were unfamiliar with maybe what that looked like, then you could take, you could create a table of values and you could substitute values of x, 1, 2, 3. You could substitute them in for x and get out y's. That's what we just said, okay? So really, absolutely no difference. This is just, this whole lesson is a fancy way for writing and doing this. Okay, it's a different notation, and we use it for functions. Okay, so when I go over here, all I've done is I've taken y. I'm going to replace y with this fancy thing f of x. Okay, that's what this is. So you can see they're the exact same equation. I'll erase the stuff I wrote so you can see it. They're the exact same equation. We've just replaced y with f of x. Okay, and then you can see there, the way that that is read is that f of x is some value, or the value of x at f of x. Okay, so what we're going to do, what we like about this is it's a mini table of values, but I'm only getting the values that I'm really interested in. Okay, so I don't have to produce the whole like 1, 2, 3, 4, 5, 6. I just want, in this, the first example, I just want the value, I want the y value when x is equal to 6. That's what that reads. Remember, see that? Okay, so it gives you a function, the function from the first part. Okay, and what it says is, okay, everywhere there's an x in my function, this being my function over here. Okay, here's my function. Everywhere I see an x, I'm going to replace it with a 6. Ever see that? Okay, so it's like a table of values, but just for a specific entry. Okay, so we're going to say, okay, f of 6 is 3 times, oh, I see an x, replace the x with 6, plus 1. Okay, and so you're going to go f of 6 is equal to 18 plus 1, so the value of f of x at 6 is 19. Now let's just recap what that is. What is that? What does 19 represent here? Let's put it like into our simpler terms, from like our grade 9 terms. What does it mean in our grade 9 terminology or like ideas, Priya?
Y.
It's y. Okay, so if I were to plot the graph 3x plus 1, it would have had a y-intercept of 1, and then we would have gone up 3, right 1, up 3, right 1, up 3, right 1 a bunch of times. And at some point, I would go through the point 6, 19. Everybody see that? So this is just a fancy way of going, okay, if I had an xy table, like a table of values, and I went 1, 2, 3, 4, all the way down to 6, the value for 6, or the y value for that corresponds with x equals 6 is 19. So that's all that's saying. It's just a fancy way of writing it. Okay, and so I don't need all of this. I know what this means now, like this. Okay, so it's a nice short way to do this. All right, and so not a whole lot different in the second question. We're just going to substitute a different value in. Okay, so what if I wanted to know what the y value of the graph was when x was -2? Okay, well, let's go 3 times -2 plus 1. So f at -2 is going to equal -6 plus 1. Okay, again, the y value that corresponds with x being -2 on this graph is -5. That's where the graph would be if I shuffled over to -2 and I looked for the graph. It would be down at -5. Okay. Is everybody okay with that? So the only difference between the first example, where we've got a and b here, what we just did, and the second example is Look at why don't you look at the form of what's been given to you? What's changed? Why don't you try to observe what's changed from the first example, AB, into the second example, and then try to extrapolate what that might mean. What did they give you this time, Kira?
A Y.
They gave you Y this time instead of X. Okay, so no different. We've done this before when we solve linear equations. Okay, I've been given different information and I can solve for the other one. Either way. Okay, so you can see here f of x is 22. Okay, so wherever I see the f of x, I'm going to replace it with 22. Where do I see f of x? Right here. So 22. Ever see that? Where I see f of x is 22. So if I see f of x anywhere, it's 22. Just replace it. And remember, I'm going to bring your attention back to, remember, f of x is just a fancy way of writing y. Those two things are interchangeable, right? So for a moment, for your purposes, if I redid this and I said, okay, y equals 3x plus 1, and I want to know what x is when y is equal to 22, that seems a little bit like that's what you've seen before. Everyone agree? That's all this is saying. It's just a different way of writing it, okay? So you just take, oh, it told me what y is, so I'm going to replace it with 22 is equal to 3x plus 1. Ever see that? And then you can solve for the thing that's missing, okay? So I'm going to get rid of that because, well, I'll put it over here. And we'll call it a side. How about that? Okay, so 22 is equal to 3x plus 1. Let's solve for x. Take away 1, take away 1. Are we okay? So to finish the question off, let's just write down the function notation. So f of 7, what is f of 7 equal to? Yeah? That's 22. It's like a mini, it's just one chunk of the table values. Done. It's one value that I'm interested in, so I'm just going to write the one value. Here's x. Again, the same thing as writing 722 xy. Can we see that? It's just a point. Hannah?
Why are we interested in finding just a single point because to draw one 2 points?
Yeah, so we're going to move, obviously, like when you get into this year we're going to do things other than lines. And you might be interested in just one particular value, right? So like, let's say hot topic, COVID, right? So COVID would have had like some sort of algebraic expression. It doesn't matter what it is. But let's say I'm interested in the number of COVID cases after, I'll just use this example. How many days did it take for the number of COVID cases to reach 22? Right? Not right, but 7. Took 7 days for the number of COVID cases to reach 72. You know, see what I'm saying? You're interested in specific values. You have something that represents a particular situation, and then we use function notation to kind of like clearly organize particular points of interest instead of having to write the whole table of values. Okay, so I can use a little bit of algebra to find 2 or 3 points instead of having that whole table of values there and having to look through it to find the value that you're interested in. Okay, so it's kind of nice from that standpoint. Okay, so you can do substitutions into equations, but you can also use function notation to read values off of a graph. Okay, and I forgot to mention this in last period A, so I'm just going to take the time to mention it now before we get into the homework section. There's a whole bunch of reasons why we like function notation, but I think the one that you could probably appreciate the most is, do you remember last year when we were graphing lines on the same grid And then you had to go, and I said, you have to tell me which one is which, right? Which is fair. And then you had to go, okay, I got to write y equals mx plus b on one, and then I got to go y equals mx plus b on the other one. You know what I mean? That got a little bit, first of all, it got annoying, and second, sometimes the equations were ugly and hard to read, and the lines were close to, you ever see what I'm saying? Not the best way to label stuff. So we like function notation because we can see right here. Sometimes we can have a function that we can call f of x, like we did in the first one, right? So we could have a function called, sorry, that's not a good f of x, but there's nothing stopping me from using the whole alphabet and calling another function g of x, or h of x, or z of x. You see, much nicer to label graphs. Would everyone agree? Very quick. And you know which one you're referencing. So we like it for that standpoint too. And when I have multiple graphs on one grid, I can call one f of x and one g of x. And then I could ask you, what's the value g at 2 versus what's the value f at 2? Ever see what I'm saying? You know which graph to go and look at. Instead of having to go y equals mx plus b, y, it's annoying. Okay, we're trying to like condense and make things very clear and concise. That's kind of what this is doing for us, okay? So before I forget to mention that, because I think there's a couple questions where there's like two different graphs and it's referencing f and g. So just have that in mind when you go. It's asking you for values on one graph versus values on the other, okay? So what we're gonna learn here is how to read, just like usual, like a table of values, how to read values off of a graph. Okay, here's your graph. We could say, I'm gonna presume that this is g of x, okay, because we've used the variable g here. Okay, so there's your graph of g of x, and I want to know what's question A asking me for? Remember, g of x is the function. So what's been replaced in my function notation? Kiera? The x. So if I'm given the x, what's the only other thing that I'd be looking for? The y that corresponds with that x. Does that make sense? So let's go find where's 2 on our grid? Right here. Where's our graph? Where's our graph? You're reading a point. You have the x value. What's the y value of the graph when it's right there? It's right here, right? What's that y value? It's just 1, right? So the value, the y value of the graph when x equals 2 equals to 1. We see that? Do we want me to write that in words? I'll write the first one in words and then you got it, okay? And you can copy it or not copy it, okay? The value, the y value, sorry. Okay, the second one's just a practice, another practice version of the first question. So what do you think is going on there? Again, they gave us an x. The only thing I'm looking for, if I'm given the x, the only other thing to look for is what? It's just y. We're looking for y, right? So where's -1 on our x-axis? I think it's right here, right? Am I right? Where's the graph? Look up. Oh, if I look up when I stand at -1, I don't see a graph. Not there. Let's look down. Where do I see it? How far down is it? Kara? It's -2. Okay. Okay, so again, the y value of g of x when x is equal to -1 is -2. Now the last one's just a little trick. What's different about the last one? Yes and S? They gave us the y value this time. So the only other thing to look for when they give you the y is the x. Where's the y value of interest that they've told us? 6. Where is what values of x correspond with the graph being at 6? So let's go find the y values that are 6. That would be, let me get a different color. Oh, where are the y values 6? Oh, it looks like the graph is at 6 here. Everyone agree? Okay. Where are the x values that correspond with that? Well, just read down. Where do those 2 yellow lines hit the x-axis? What are the x values? Yes, Asin?
3 and minus 3.
3 and negative 3. Right, so we can write this. Okay. G of negative 3 equals 6, and G of positive 3 equals 6. Right? Right here. Okay, very important. It's just a fancy way of table values. That's all it is. Okay, and just be a little careful, a little bit of thought into which one did they give me, X or Y, and then tell me the other one. That's all it is. Okay, just a fancy little notation. Saki?
Can the final answer be written in a column?
Yeah, let's do whatever the answers have in the homework that I give you. Okay, just formula. I think maybe they leave it like that, but either way, I think it's okay. I get what you're saying. Either way, it is a point. It is a point. It doesn't change the fact that it is a point. So I think if you wrote that, Saki, it wouldn't be wrong because it is a point. But just see what the back of the textbook says, okay, for reference, or whatever homework is there. Okay. Okay. Next one. We also get to have a little fun by taking functions and putting them inside other functions and seeing what comes out. That sounds like fun. So this is I made this question a little easier. It had a squared on it for the other class, which we haven't done yet, so I just made it easier, okay? Basically, whatever is here on the inside of that bracket, whatever it tells you to substitute it in and simplify. That's it. Okay, wherever you see an X, right, I'll write this in words. Right, remember this is h of x. It's just, we've replaced the x with something. So, wherever you see an x, substitute n plus 3. Right, so let's go to our equation. I'll let you write that down, sorry. Copy. Is that big enough for everybody to see? You see it? Okay, so if I come over here and I try to evaluate everybody see? Okay, what do you think you can do now? Think you're done? Is that simplified? We know what to do there. We've seen that before, right? Do you remember what we call this? Oh, Andrita was up first, I think. Yeah, expanding or distributing the coefficient into the inside of the brackets. Okay, those are the words that we used. Okay, so 2n plus 3 plus 6n plus 18. Kara?
Wouldn't it be 6?
Yeah, oh yeah, sorry. Yeah. Okay. And now what? Is that simplified? No, you clean up the like terms, right? So I can go 2n plus 6n plus 6 plus 18. So we're going to get 8n plus 24. Fully simplified? Ooh, interesting answer. Who says no? Who says yes? How come no one voted? We're gonna do a bit of this in here. That's actually not fully simplified. We're gonna do this work in here, so it's not, I'm not surprised. There's a little bit of hesitation there, okay? What we're gonna learn in here, this is called common factoring. And what we're gonna learn is you look at, how many terms are there? Two, there's two terms, ever see that? So we kind of talked about that in that little review package the first couple days, right? There's two terms there. What we're asking you to do to fully simplify is ask yourself, is there anything common across the two terms that you see, or three terms or four terms? So that is a loaded question, and it has a couple things in there, but remember, terms are made up with coefficients and variables. Okay? Is there anything that both coefficients can be divided by evenly? Freya? 8. Okay, so if I divide something by 8, do I just write this? Yes?
You have to put brackets around it and then add it or multiply by.
Multiply, yeah. So just like usual, we can't just remove something from a question and say, oh, look at this. It's a whole new question now, right? So if you divide something out, what's the opposite of dividing something out? Or what's the opposite of dividing? Multiplying. Okay, so if you divide something out to remove it, you can't just make it disappear. You got to multiply by it in order to counteract that. Now, I think we spent a bunch of time going over, as we've already seen, and I felt pretty good when I asked you this question, expanding. But we did not spend very much time in grade 9 going in the opposite direction. That's what this is. We're going in the opposite direction. We're removing stuff from the inside of brackets instead of putting it in. Okay? That's called factoring versus expansion. Those two processes are opposite. Okay? How do I know I'm right? How do you know you're right if you do this on a test without having answers? If you've done this correctly, you take your skill of expansion. If you expand that back in there, you should get the original where you came from, if you've done it correctly. And that goes for more and more complicated questions, right? So if I expand that back in, I'm going to get 8n plus 24. I'm good. I know I'm right. Okay? Are we good? Don't stress about that too much. Okay, it just said simplify, so I just brought that to your attention. Okay, we have a whole part of the course to deal with that, like 2 or 3 lessons, 2 lessons. Okay, common factoring. Okay. Okay, nothing too much different here. Okay, just a couple extra practice questions. Again, it tells you what to substitute, so substitute it and go. Okay. Oops. Oh yeah, I'll talk. I did that very fast and we didn't do any talking, so there you go. Okay. So in reference back to Safi's point, maybe is it a point? They are points, but you could see how that might be a little difficult to write as a coordinate point. That's not I don't know what that is, right? That's why function notation's nice, because we can write it. Okay, the value of the function when I substitute 2 minus 5w in is 15w minus 1. Right? So whatever it tells you to substitute it. And then do any of your raw skills that we've done before to simplify it as best you can. Okay? And then, doesn't matter too much here, but just from a formalities perspective, we always said write it in descending order. Remember what that means? Said this a bunch of times across the 3 classes. I'm teaching 3 classes that are, the grade 9s aren't too similar, but this class and the grade 11 class are quite similar at the moment, okay? That has a exponent of 1, okay? And this has nothing on it at all, so that's descending order. Okay, if there was a squared in there, it would go the squared, the 1, and then the 1 without anything on it, okay? Just a formality. Okay? Okay, I changed this question specifically for you just to test whether or not you remembered what we talked about yesterday. You want a moment to try this on your own? Can you tell me what the value of the function is when x is negative 2? Why don't you take a second and see what you get? Anybody get an answer? Still working? Like, this is a intentionally mean question, I would say. Meant to make you stumble. But it gives us opportunities to talk about a couple things. Addison?
I got an answer, but I don't know if it's right.
Well, that's okay. What is it?
G negative 2 equals negative 6.
Okay, we're close. We're close. Or maybe I'm wrong. Thomas, what'd you get?
No, I don't have an answer. Do you substitute in the negative 2 for the x squared?
Yeah, just wherever there's an x, you substitute the negative 2, and then the squared will be on the negative 2. Yeah.
Thank you.
Okay. Close. That's close. Maybe I did something wrong. We'll find out in a sec. Anybody else get negative 6?
I got the same.
Oh, you got negative 6 as well? You got negative 6 as well? Everybody got negative 6? What? I don't think I did anything wrong. Okay. Did all of us get negative 6?
No.
What'd you get?
Negative 14.
Ooh. My answer has a 4 in it, but it's not 14.
Yeah.
All right, you want me to show you? Let's show you. Okay, we'll talk about it. Good opportunity here. There's a few of us that have obviously done it right, and I've done something wrong, or a few of us have made a common mistake that we can all learn from. And some of us have made another mistake that all of us can learn from. I don't know. You tell me if I'm right or wrong.
How did you get?
Ah.
Yes.
Oh, I don't know.
Alright.
I don't know. Uh-oh. Okay, so don't do what I did, because that doesn't make any sense at all. Who sees my error? Don't ask me why I did this, because it makes absolutely no sense. I don't know how 2 turned into 4. Don't know. 2 should be 2 unless you multiply it by 2. So, there you go. I think somebody's correct. I was wrong. I thought maybe I was wrong. What do we get? 6. That's 6. Yay! Having a hard time with basic math today. Hooray! Okay, another example of just a question on the front. Is everyone okay with that one? Okay, why did I intentionally give you that question? Because we talked about what yesterday? The one above. Yes, Andrea?
The exponent
The exponent laws and the use of brackets when you substitute things into functions. Okay, because somebody maybe just typed in, did this. And we know what's going to happen there. A -4 plus 2 minus 12. Okay, gotta put the brackets around so that the exponent touches the -2. So I put that in on purpose. Okay. Next question is very similar to it's just another practice example, just so we can make sure we've got our bases covered. Okay. It told us what? It tells X or Y. What did it tell us? It told us Y. Okay, and I know that's the case because I see X present. Okay, and I don't know what it is. So it's asking me to find it. Okay, so h of x, this piece is equal to 23. So I'm going to take that piece and replace it where h of x is. Okay, and then it's just solve. Just solve for the thing that's still sitting there. So x is the thing I'm looking for. Okay, one more question. You tell me if you got a problem with that. Any problems? Wait. I don't know if I did anything wrong on that one. I got the same answer earlier. Or maybe I got it wrong. You're all very critical of me. I only made one mistake. It was a very small one. Don't be so critical. Have some trust. I gotta redeem the trust, apparently. Are we okay for surezies? Okay. There's probably a couple questions that are going to be a little bit tricky. Like, this is a pretty straightforward question for the purposes of the lesson, but you're probably going to encounter a couple that are maybe a little trickier. So, let's have a process. Can anybody tell me what h of 2 is right off the top of their head? Maybe with a simple question like this. But with other questions that are a little tougher, particularly around the equation that's been provided, you might not be able to do that right away. So, I would say step 1 is find h of 2. So let's find h of 2. Okay. So h of 2. Oops. H of 2 is going to equal 4 times 2 plus 3. 8 plus 3. H of 2 is equal to 11. Are we happy? Okay, again, all I'm doing, fancy way for taking, just tells me what x value to substitute in. I substitute the x value in and find what y corresponds with that x value. That's it. Okay. Now this question is just a little trickier because they want, okay, I'll do the next one and then we'll talk about what this is asking us for specifically. Okay, and I'll write it down. So step 2 would be, okay, I don't know what h of 1 is. So let's go step 2, find h at 1. I'll move that up too, sorry. Maybe somebody can't see. Okay, so let's go h at 1 is equal to 4 times 1 plus 3. 4 plus 3, 7. Okay, does anyone want to have an attempt at contextualizing what this question's actually asking me for? You can ponder on that for a sec. If we have a brave soul raise their hand to give an answer, we can. So again, just one more time. What is this question actually asking me for? Because with the new notation, I think it can get a little bit confusing. right? But it actually is not crazy. Not crazy. Addison?
What does h of 2 minus h of 1 equal?
Okay, so that's right. That's good. But let's replace what is h of 2 and what is h of 1. Not numerically, just generally. Hannah?
The value of y when x is
That's
2
right.
minus the value of y.
So it's asking me for the difference in the y values that correspond with each of those 2 points. Okay, basically the rise between the points. That make sense? Okay. So I'm finding 2 y values there, and then they're asking me to subtract the 2. So I'm finding the difference between the 2 y values, right? That's what that says. Find the difference in the y values when x equals 2 and x equals 1. Okay, I'll let you write that down. Then we're almost done. Okay. So, h of 2 minus h of 1 is going to equal 11 minus 7. Do we have any questions?